let's start with today's first problem. The efficiency of an Otto cycle is 60% and gamma is 1.5. Find the compression ratio. So let's start with the given. Here 2 points are given, that is the efficiency of the Otto cycle is 60%. That means the value of eta is 60%, that is equals to 60 by 100 equals to 0.6, and the value of gamma is also given, it is 1.5, and we need to calculate the compression ratio, that is we need to calculate the value of R. Now firstly we need to write the formula for efficiency of Otto cycle, that is eta Otto equals to 1 minus 1 by R to the power gamma minus 1. Now by putting the value of eta Otto and gamma, we can easily calculate the value of R. So eta Otto is 0.6 equals to 1 minus 1 by R to the power 1.5 minus 1. The value of eta Otto is given as 0.6 and gamma is 1.5. That is 0.6 equals to 1 minus 1 by R to the power 0.5. Now 1 by R to the power 0.5 equals to 1 minus 0.6, just changing the position of these two terms, that is R to the power 0.5 equals to 0.4, sorry, it will be 1 by 0.4. R to the power 0.5 equals to 1 by 0.4 means 2.5. Now this to the power 0.5 means root over, so therefore the value of R will be 2.5 square, that is 25 square is 625, and for the point it will be 6.25. so this is the value of the compression ratio. So this is the next problem. An engine of 250 mm bore and 375 mm stroke works on Otto cycle. The clearance volume is 0.00263 meter cube. The initial pressure and temperature are 1 bar and 50 degrees centigrade. If the maximum pressure is limited to 25 bar, find the air standard efficiency of the cycle. So as the engine works on Otto cycle, so this is the PV diagram for the Otto cycle, where this process 1 to 2 and 3 to 4 are the adiabatic processes, and process 4 to 1 and 2 to 3 are the constant volume processes. So just let me give this arrow. Now this VC is the clearance volume and VS is the swept volume. So now let me write the given part. So what is given in the question? It is the bore diameter, the stroke length 375 mm, the clearance volume, that is VC, is given, the initial pressure and temperature, that is P1 and T1, is given, and the maximum pressure is limited to 25 bar, that is P3, is given. So I have written all the given data here and changes the units wherever necessary, just like D equals to 250 mm, that is 0.25 meter, L equals to 375 mm, that is 0.375 meter, VC clearance volume is 0.00263 meter cube, P1 is given 1 bar, T1 is 50 degrees centigrade, that is 50 plus 273, 323 Kelvin, and the maximum pressure P3 equals to 25 bar. So if we put this data on the graph, that is, this is the P1, that is 1 bar, this is the P3, that is 25 bar is given. Now first we need to calculate the swept volume. So basically this is the volume through which a piston moves to make the complete stroke. So the formula for swept volume, that is Vs equals to pi by 4 into d square into L. So pi by 4 into the value of d is 0.25 meter, that is 0.25 square, into the value of L is 0.375, and by calculating this value we get 0.0184 meter cube. So this is the value of swept volume. Now we need to calculate the value of compression ratio by using this formula: swept volume plus clearance volume by clearance volume, and we know both the data. So Vs equals to, we have just calculated, 0.0184 plus the clearance volume is 0.00263, it is given, by 0.00263, and by calculating this value you will get 8. So the value of compression ratio is 8. Now for the air standard efficiency we need to write the formula eta auto. I have written this formula in the previous problem: 1 by r to the power gamma minus 1, that is equals to 1 minus 1 by the value of r is 8, and the value of gamma is not given in the problem, so for ideal condition we will take 1.4 minus 1, that is 1 minus 1 by 8 to the power 0.4, and by calculating this value you will get 0.565, that is 56.5%. This is the air standard efficiency for the Otto cycle. So this is the end of the problem, but sometimes in this kind of problem there was a question to find out the mean effective pressure of the cycle. So let me show you how to calculate the mean effective pressure. So the formula for the mean effective pressure, that is PM, equals to P1 into R to the power gamma minus 1 into Rp minus 1, where Rp is the pressure ratio, gamma minus 1 into R minus 1. So all the terms here is given to us except this Rp. So first of all we need to calculate the value of Rp, and for Rp the formula is P3 by P2, where P3 is given, that is the maximum pressure, and we need to first calculate the value of P2 here. Now for the process 1 to 2, as this is the adiabatic process, so we can write P1 V1 to the power gamma equals to P2 V2 to the power gamma. So the value of P2 equals to P1 into V1 by V2 whole to the power gamma. So P1 into V1 by V2 means compression ratio, that is R to the power gamma. So that is 1 into 8 to the power 1.4, and the value will be 18.38 bar. So P2 is calculated 18.38 bar. So the value of Rp, now we can calculate it, that is P3 is given, that is 25 bar, by P2 is calculated, that is 18.38 bar, and the value is 1.36. Now we have Rp equals to 1.36, we have P1, that is 1 bar, R is 8, gamma is 1.4, and by putting all these values you can easily calculate the value of PM, and the value will be 1.334 bar.